So this next aspect of the chapter concerns multiple actions. It isn't always just flipping a coin or just drawing a card. Sometimes more things are happening at the same time, and you have to consider that. The use of language is very specific. Like the use of and versus or. When the word is and, both, when those words are used, we multiply the probabilities of the events together. So we're multiplying the probability of each event. If the word is or, if something happens or something else, you add the probabilities of each event. So let's say we're flipping a coin and we're rolling a die. So those are two actions that are happening at the same time. So what's the probability that you flip a heads and roll a 3? Well, that word and means we are going to multiply. So what's the probability of flipping a heads is a half. Rolling a 3 is 1 out of 6. When you multiply those, when we multiply fractions, you multiply across the top and the bottom. So there's a 1 in 12 chance that you flip a head and roll a 3. With the word or, we add. So you flip a tails, that's 1/2. Roll a 4, 1 out of 6. Now to add and subtract fractions, we want to make sure they have like denominators. So I'm going to make them have the denominator of 6. So there's a 4 out of 6 chance that you flip a tails or roll a 4, which reduces to 2/3. You can also, with one action, still use or. So let's say I'm rolling a die, and I'm okay if it's a 2 or a 3. So we're going to add. So the chance that it's a 2 is 1/6. The chance that it's 3 is also 1/6. So the use of language is very specific. Another specific use of language is the words with replacement. So when you're doing something with replacement versus without replacement. And we use this when selecting from a group more than once. So that could be drawing from a deck of cards more than once. So let's say you want to draw 2 cards out of a deck. What is the probability that they will both be hearts? So with and without replacement, with replacement essentially saying, all right, you draw a heart card. Replacement means you put it back, and then you draw a heart card again. Versus without replacement means you draw a heart, keep it, and then you draw another heart. Now let's keep in mind what a deck of cards is. You have your hearts, you have the clubs, you have the spades, and you have the diamonds. Each one goes from ace to king, so there's 13 of each of them. And there's 52 cards total. That's really important, especially when we're using decks of cards in this chapter a lot. So, what's the chance I draw a heart, put it back, and draw another heart? So, the word is both, so we're going to multiply. drawing a heart is 13 out of 52. 13 of the 52 cards are hearts. I put it back, and now, okay, there's still 13 out of 52. So that gives you 169 over 2704, which reduces to 1/16. So if you do that with replacement, you're putting it back, there's a 1/16 chance you're going to draw 2 hearts. Now this is different if you keep it. You're not replacing it. So there's 13 out of 52, but now you have a heart. So there's only 12 hearts left in the deck, and there's only 51 cards left in the deck. So that gives you 156 over 2652, which reduces to 1/17. So there is less of a chance that once you keep it, because you've reduced the number of hearts in the deck, that you draw another heart, and that's why that one's slightly less. Again, language is very specific. So let's say you draw 2 cards of the deck. What's the probability that at least one of them is a face card? So the key words in here is at least one of them is a face card. Because that means I need to take the probability that 1 is a face card, and I want to add the probability that they're both face cards. So let's remind ourselves, for face cards, there is the Jack, the Queen, and the King, and there's 4 of each. So there are 12 face cards in a deck out of 52 total. So, with replacement, so the probability that 1 is a face card, you also have to consider the order. Maybe the first one is a face card and the other is a number, or the first is a number and the second is a face card. There's a lot of different things in play here. So with replacement, well, the probability that they're both a face card would be 12 out of 52. You put it back, you replace it. 12 out of 52 again. That's 144 over 2704, or 9 over 169. So that could happen, or the first one is a face card and the second one is a number. So there's 12 out of 52. So that means how many number cards are there? There's 40 of them, which is 480 over 2704, 30 over 169. Or we have the probability that you draw a number and then a face card, which, because we're replacing it, the fractions don't change. You should get the same thing. So because they could both be, or it's a face then a number, or it's a number then a face, what do we do with the word or? We add. So with replacement, if you put that second card back, 9 over 169 plus 30 over 169 plus 30 over 169 gives you 69 over 169, which as a decimal is 0.408. So it's about 41% chance that if you draw 2 cards, if you're using replacement, you'll get at least one face. Without replacement, well, what's the probability that it would be both? I'm just going to do one of these. Well, it's 12 out of 52. Now it's 11 out of 51. Oh, there's only 11 face cards, so 12 times 11 is 132. 2652. And then let's say the probability that it's a face and then a number. 12 out of 52 times, well, there's 40 number cards, and now there's 51 cards left. So 480. That's a 2. Not a good 2, but it's a 2. Or the probability that it's a number and then a face. So 40 out of 52, and then the 12 faces out of 51. You add those together, you're going to get 132, 480, 480, so without replacement, the probability changes. You reduce that to 7/17 or 0.411. So the chances are actually really close, but it does change a little bit depending on if you put that second card back. All right, the last part of this video is some more practice.